So it looks more like the wheel of a cart. When you don't quite know what the new form should be, you tend to mimic or echo the earlier forms. So engineers are good at making things work. They're good at understanding reality, like materials, costs, manufacturing processes, and the laws of nature. And they're usually pretty serious people, okay? These are tough things to engage with. Maybe they're
fun in engineering.
Well, maybe when you get them in the pub later and they let their hair down, they go berserk. But a lot of what they're doing is serious, enclosed stuff. And when I talk about it in a minute, I think they're very good at converging, okay, rather than diverging. I come from a different tradition, and I belong to a group of people who are really mad divergers. Here's a product that I think is new and is quite nicely engineered. You think of the problem we got on the desktop now when we got all these bits of gear, and we really want it to be modular, and we really want it to talk to each other. This is a newly released product that's called Bug, and this is things like cameras, printers, computing, all put together in a systematic way. So there's a kind of engineering intelligence behind this. I don't really care what the designers were called who did it, but they got an engineering intelligence which is about the system, about dimensions, about modularity, about interchangeability, about connectivity, okay? Taking up the thought that engineers are the people that primarily make things work, you've got to remember that most things don't actually work. Almost every artifact you come across or use will have shortcomings, you know. Almost everyone you can think of. You say, oh, well, an aeroplane is a huge technological achievement. It'll take me from Auckland to Sydney, but it guzzles a lot of fuel, and it's got a tendency to fall out of the sky now and again, you know. Or you're sitting on a bench here and you think, oh, this is quite comfortable for now, but in half an hour or so it becomes less comfortable. So almost everything can be improved. This is a mad inventor called Clive Sinclair, a British inventor that wanted to make an electric tricycle, which was, you know, environmentally friendly, low energy, but he saw it in being positioned in this kind of environment. So it's in the sense of where it's not that the technology is stupid, it's actually his conceptualization of where it should sit. And you can see that it's just massively dangerous. It disappeared as a business. It's called the C5, this thing. But you see it occasionally because they run it on golf courses or the promenade of seaside towns, where it comes into its own. It's a perfectly acceptable vehicle. So having a good artifact has to be matched to the good environment, okay? What are the essential skills of engineers? Well, I think they run something like this. Drawing, which is a long history, which is only a form of modelling, and by modelling I mean three-dimensional or four-dimensional modelling, and the whole thing encompassed in some sort of system of prototyping. So if you're a good engineer, you're involved in one way or another with these techniques. And these techniques have a huge, long history, 1,000-year history maybe, or a bit less. These are early drawings about architecture, but the principles are still the same. 1234 by a kind of jobbing designer called Villard de Honnecourt. But see what he's doing? He's trying to lay down a system of how you might replicate certain forms in stone in a building. So once you crack this system, which is two-dimensional drawing for three-dimensional objects, your ambitions can be enormously enlarged. So even though they weren't on top of the kind of drawing systems that you use in ArchiCAD or whatever, or even the normal orthographic projections that you've been taught about, they would work off really quite crummy little sketches like this, and then full-scale maps on the floor, usually in plaster. They're enabled to build really extraordinary structures. So this drawing on the left is a plan of a church like Chartres on the right. The engineering process means that you iterate, that you don't always get it right first time, that you might make a huge number of models in any one product that you're working on. James Dyson here, who designed the Cyclone vacuum cleaner, claims to have made 600 or more models and prototypes in getting this artifact right. So each time you tweak it, you make another. These are very early artifacts. Those of you that are interested in vacuum cleaners, the one slide on the left shows that he's using one of his competitors' vacuum cleaners, which is the Hoover Junior, to power the cyclonic device that he's working on. And look how crummy it is. It's all cobbled together. It doesn't really matter. He just wants to demonstrate the principle and move the idea forward. James Dyson was trained as an engineer, but he also did a course in industrial design at the Royal College of Art in London. Edison is cited as being a very brilliant person, not just because he had engineering and creative skills, but because he systematized all that process. Had a big lab where they go through lots and lots of different experiments. In this case, looking for the filament that would be an appropriate light source for an electric light bulb. So the little sketches and drawings are the embodiment of the system of investigation. 1890s. So the first message is keep drawing, keep modelling, because this is your way of thinking. This is how you think. This is a drawing from Leonardo of a parachute, enormously prolific. You've probably seen illustrations from his notebooks, and what they believe is that they found about 7,000 pages that exist, and that there are about 28,000 that they believe to exist. So his productivity in terms of sketching and drawing is about 1.5 pages per day. So he's massively productive in ideas and the way he presents things. So there'll be stacks and stacks of them, and we've only found a relatively small proportion of them. What other kind of things are engineers good at? Biomimicry is quite a hot topic. Here is someone designing something that doesn't just mime a natural product, but is using it to make the architecture. This is a growing building by an experimental group in America. So this would be like a low resource, long-term project. Would it work? Well, who knows? You have to wait and see. Here's a rather nice bridge designed by a structural engineer called Ove Arup, who's Anglo-Danish, and he said he was designing this bridge so it looked like sticks of rhubarb, so it's kind of growing, and it supported this slender beam across the top, which is a pedestrian bridge. So the little sketch on the left is his first conceptualization, and there's an image of the thing that was in his mind, and there's the finished product. These initial drawings don't have to be very good. They can be quite crummy. They're just capturing the idea. Ove Arup then, later in his career, was the engineer for the Sydney Opera House, and strangely here's a few drawings of that. The drawing at the top is the first conceptualization, and then the drawing at the bottom is as it was realized. So it's much more regular. Do you know the story of the Sydney Opera House? Well, Utzon, who was the architect, also a Dane,